Hey, welcome back everybody. And the last time we were together, we introduced vocabulary and we started looking at particular scenarios. For those of you that were worried, I couldn't spell combinations, whoopsie, let's make sure Monty can spell the word combinations. And if you didn't watch to the end of the last video, I misspelled the word combo and combinations and combinations. Couldn't figure it out. Had to Google it. So there we go. Alright. So now we're in these scenarios. Now that we've done these scenarios and we did this fundamental counting principle, we want to keep in the back of our mind independent, dependent. This dice is independent of this dice. Okay, when I roll this, it does not have an effect on this. It has an effect on the total number of possibilities, but it's independent. So let's just keep that idea in the back of our mind as we go through the following scenarios. Here we go. Okay, calculate probabilities and of independent events. Okay, the shell game. Okay. The shell game consists of placing 3 opaque cups representing shells upside down on the table, hiding the ball under one of the players. The player who has not seen where the ball is hidden has to choose one of the 3 cups if the ball is hidden under it. If the player wins, what is the probability that the player will win 5 times in a row? 5 times in a row? I don't know. Okay. So, now, shell game. Shell game. Okay, we got a ball. What's the probability of picking a winner? What's the probability of picking a winner here? Okay, 1 out of 3. So, what's the probability of picking another winner? We do this 5 times in a row. Probability of getting a winner, 1 out of 3. Now, what's the probability of hitting 2 in a row? Hitting 2 in a row is 1/3 times 1/3, which is 1/9. Okay, let's do it again. 5 times in a row. The probability of hitting this 5 times in a row . 1/3. So now 1/3, 1/3, 1/3 equals 1/27. And do it again. And just keep working these problems until you see the pattern. Okay? Probability of winning here is 1/3. But the probability of hitting all 4, 1/3, 1/3, 1/3, 1/3, 1/3. 4. Getting ahead of myself. 1/4. This is 1/81. For those of you that can't read my writing. That was 27. Okay, and then we'll do the last one. 1, 2, 3, 4, 5. Probability of hitting 5 winners is 1/3, 1/3 the probability of all the individual ones multiplied together. Okay, 1/243. All right, now pause the video, have a little discussion over that, because that's what we're going to do on each of these problems. Okay? Whoop. All right, spin the spinner. What is the probability that the first 2 spinners land on a 1? Pause the video, have a discussion. Okay? Alright, welcome back. This is nothing different than the dice. Okay? Remember the dice problem? What's the probability of rolling a 5 on the yellow? 1 out of 6. What's the probability of rolling a 1 on the orange? 1 out of 6. 1 out of 6 times 1 out of 6 is 1 out of 36. You can look around the room, you see those charts. Mr. Miller has that chart of dice. Same idea here, okay? We're only looking at the first 2 spinners, so if we get it out that, and we want to land on a 1. Well, this is 1 out of 6. This is 1 out of 4. We multiply to get the total number of combinations, 1 of the 24 total. Okay? All right. So, if you need to, pause the video. It's the idea of the dice. Look at that big chart and see it. A 1-1 through a 6-6. The probability of. All right? You randomly choose a marble from each set. What is the probability that both marbles have stripes? Okay. Now, independent. You see how they're independent? You got one box, you got another box. These are independent acts. Independent. I'm actually going to write that. Independent. Okay, and stripes. 1, 2, 3, 4, 5, 6, 7. How many? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Seriously? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, 7 of the 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, you say you can get a different answer depending on how you counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Stripes. Stripes. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting 9. I'm getting 9. Better check my work. Yep. 17, 18, 9, and 9. Okay, now, randomly choose what is the probability of getting both. Okay, now, let's do some formal math here. Okay. If we look at our cheat sheet, independent events, the probability of A and B happening is the probability of A times the probability of B. Okay? So just like on the dice, let's all write one of these out. The probability of A and B happening is the probability of A times the probability of B equals 7 over 17 times 9 over 18, which makes sense. 17 times 18, that's how many total possible combinations there are. Let's grab a calculator. 7 times 9, so we got 63 of these, and then we got the big number. 17 times 18, 306. Okay, now it's up to you if you want to try to simplify that. I'm seeing a 3. Let's change colors here. 3 times 21, 3 times 102, 21, 102. 3 times 7, 3 times 34, 7 over 34. Check our work. Let's grab a fancy calculator. Remember, all you got to do is take 63 divide by 306. Hit the math key, convert to a fraction, enter, enter. Ha! Ding, 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 ding. Oh, ring the bell on that one. Okay, so formal math. The probability of event A and event B happening is the probability of A happening times the probability of B. All right? Okay, again, we're not in a hurry. The key is to work through each situation and make sense of it in your mind. Okay? All right. You randomly choose a block from the set of the diagram. What is the probability that you will choose a block labeled with a T or is or different than A? Excuse me, is or different than and? Okay. You randomly choose a block from the set in the diagram. What is the probability that you choose a block labeled with a T or a block with a 6? A T or a 6? Have any ideas? Well, the first thing we should do is let's label this T. Can't see the color, right? Alright, T. What is the probability that you choose a block labeled with a T or a 6? You randomly choose a block from each set. Kind of shows up nice, doesn't it? You randomly choose a block from each. All we're going to do is pick and pick, right? Let's just write that out. 1, 2, 3, 4, 5, 6, 7, 8. Oop, 8 total. 8 total. And we want one of the 8. Over here, it's 2. 1, 2, 3, 4, 5, 6, 7, 8. 2 of the 8. Okay? Aren't we just adding them together? I would say we just add them together because it's not this and this together. It's not like this. Okay? What's the probability of rolling a 2 or rolling a 5? 1 out of 6 and 1 out of 6. Add them together, one or the other, or let's see if our cheat sheet helps us with this. We don't have an or statement here, so we're going to have to figure this out on our own. Oh, man. Okay, so in the dice, note, dice, if you wanted 1 out of 6 plus 1 out of 6, that's just 2 out of 6, which is 1/3 of the time. 1/3 of the time. We would add the events together when we use or. Okay, so we just add them together. This is nothing more than 1 out of 8 plus 2 out of 8. So 3 out of the 8 would be the total number of events, right? Are we happy with that? We're not happy with that? What do you think? Or. An or statement. Probability of rolling this is a 1. Probability of rolling. I like this. I like that. Okay? this or that. Okay? I think we're good. Hopefully you're good. I love the fact that we can have a discussion and say, does that make sense? And this and that, there's not very many. But this or that, well, I could pick some of those, or I could pick some of those. It doesn't really matter. We have more opportunity. Think about that. Okay. The sides of a 6-numbered cube are labeled 1 through 6. You roll the cube 2 times. What is the probability that it will land on a 1, a 1 facing up on the first roll or the second roll? Well, first roll, 1 out of 6. Second roll, 1 out of 6. What can we do with that? If we add them together, does this work? Does this work? A third of the time I'm going to win. I roll it and I roll it. Okay, 1 out of 6, 1 out of 6. Put them together. A third of the time is not going to be a 1 or a 1. Doesn't work, does it? Okay. So now we got to figure out what happened. What happened here? Okay. Let's go to our cheat sheet. I don't think we have an or statement in here, do we? Okay, these are given statements, these are and statements. We don't have the probability of an or do we? Let's go to the internet. Let's Google probability with or statements. Probability of an or statement. Okay? Go to our images and see if we can find one. Okay. Let's see if we can find an or statement here. I just saw it. There it is. There it is. Okay, now, unfortunately, I'm hoping that when you saw the second activity, we know that if we roll these 2 dice, 33% of the time it's not going to be a 1. Okay? I was hoping you would see that. Now, the probability given an or statement is the probability of the 1 out of 3. Probability of a 1 out of 3. But then we have to subtract out the possibility of this happening. Okay? So we have a third plus a third minus when it happens at the same time, because it's a double up. Okay? It's a double up. See if I can find a better example of an or statement. And or. There it is. There it is. Okay. We have the overlap. Okay. A third of the time this happens. A third of the time this happens. But when they happen together, we doubled up. Okay. The double up. Alright. So now, I love that. So let's go back here. And we have the probability of a 1 plus the probability of a 1. And we draw our box, all the probabilities. The first dice, probability of a 1. The second dice, probability of a 1. But there's an overlap when they both happen at the same time. Both happen at the same time. That's a double up. Okay. Minus when they happen together. 1 out of 6 times 1 out of 6. It's going to happen 1 out of 36 times. So 1 out of 6 plus 1 out of 6 minus 1 over 36. 2 over 6 minus 1 over 36. I'm going to use a fancy calculator here. 2 divided by 6 equals that. Minus 1 divided by 36 equals that. Math, enter, enter. Okay, 11/36 of the time this will happen. Okay, now let's go back here. Okay, 1 over 8 minus 2 over 8. Is there a double up? Probability of a t or the probability of a 6. No, I still like this. Still like that one. These are confusing, huh? Alright. Okay, now it's time for you to do. Hopefully you enjoyed this. Next week, it's all about cards. Alright? Have a great week. Mafia, solo activity. Push yourself. Hopefully you enjoy playing Yahtzee and cards. We'll see you on Friday for another game day. Bye.